Okay everybody, this is the ButtonBuddy 1.4, and what it is, it's a PLC based on Arduino Mega, and the idea is to be able to read push buttons on this switch so as to be able to detect a single button pushed at any one time or a combination of a double at each time. So let's go ahead and fire this up and I'll show you the prototype demo. So the input works on 5 volts to 12 volts. I'm just using a 9-volt battery. And I also have an LCD display here that will show us what is happening inside this controller code, as well as an oscilloscope, which you may or may not see the traces to see the output. So this is an interface box to the long-range target controller, and it's to send a TTL signal on one pin when a single was pressed, or another TTL signal when a double was pressed. And that's what the scope here is going to hopefully show us. So when you first power it up, you'll see the LCD display. It comes up with a banner, ButtonBuddy 1.4, and then it goes into the button scanning mode. And what it will do will actually tell you which button was scanned. In the field, it's going to be connected to a switch box with 20 buttons. However, for this prototype, I have a box with only 6 buttons. So let's go ahead and walk through the buttons. So I'll press a single, that button, which is a 4, if you could see it in the display. This one here. The next one, and you may not see on the scope, but channel 2 is actually going to show you that pulse, which is 125 milliseconds. I'll include some still photos to actually show that. So we'll walk around the horn, and it's detecting singles just fine, as you can see in the display. Now here comes the fun part. When you hit doubles, you press 2 of them, and it shall show you 2 buttons pushed. And in this LCD display, which is more of a debug console, it actually shows you the number of buttons pushed total. And that represents the pulses that are going to the long-range interface. So we can try any combinations of doubles, or in the field for Skeet, or in this case 5-stand, they're called a true pair. So the trapper will just go ahead and press this on the person's pull, and it incremented 2 targets, and it indicated two buttons were pushed. So you can do, and for report pairs, it's real easy. You press the first one, it registers it, and you press the second one, and it registers as a single. Same with any of these. Single, single. And so this is tuned so that if you push it relatively quick, it still registers 2 buttons. And it took some time to program the delays and tuning to anticipate what the puller may do in a less than an ideal push situation. So for example, say the trapper decides to push 2, but they don't get them both exactly the same, and there's a little bit of a stagger. So the code in here accommodates for that. So an example, I'm going to try to push a true pair here, and I'm going to simulate a stagger. So the shooter would yell pull, the trapper would go blang blang because he's less than ideal, but the code still registers as 2 buttons pushed. So we're set there. Pull. And also this red LED, what this is going to do, this is showing you the output line that's going to ultimately control a solid state relay to disable the buttons in the box. So there are periods in the code where there's a possibility that if the trapper pushes the buttons too fast, they can actually throw a second target and it won't be able to detect it to send a signal to the downrange, the long range box. So what I've done there is, for the split second that the red light doesn't blink, I'm strobing the buttons and turning them off, so that they won't ever get into that situation. So we've tried every possible scenario that I feel, and it seems to work pretty well, as you can see. So if there's any questions, you can give me a call or email me at gigabits@comcast.net. Thanks.